Hello, I'm Mark Gislow, Professor of Geography and Chair of the Geography and Geospatial Technology Department at Lakeland Community College. I want to just give you a brief introduction on some fundamentals of geospatial technology and geographic information systems in science. First of all, it's important to take into account the historical perspective that, first of all, while we live at a time in which we have an unprecedented amount of geographic data around us and the technology to be able to map real-time locations and activities on a global scale, it's unprecedented. We've never had anything like this in the past, but it speaks to a long-standing human desire to understand where we are on the Earth's surface and to be able to understand the world around us and then map it out. Eratosthenes, 2,300 years ago, who was a Greek mathematician and scientist, used geometry to calculate the circumference of the globe to within a few hundred miles of being accurate. And then a couple hundred years later, Hipparchus started to then put that map on a grid system, and we had the first initial steps towards understanding the global grid. 2,300 years later, we emerged with the technology that was developed in the late 20th century that we see around us now. It really represents a revolution in terms of how we understand geographic and spatial data, to where we're at the point where we can collect data on the spot, use GPS location systems, and have, an unprecedented amount of geographic data and information available to us. Within the geospatial field, we can identify three main areas, which are GIS, Geographic Information Systems, GPS, Global Positioning Systems, and then imagery, which involves satellite, aerial photography, orthophotography, and some other technologies like radar and LiDAR and so on. These are supported by desktop, online, and mobile mapping services, and those technologies are changing all the time, and they're a big emerging field or subfield within the geospatial area. As a new field, the U.S. Department of Labor has identified the skills that someone needs in order to pursue a career in geospatial technology, and it's part of the U.S. Department of Labor Geospatial Technology Competency Model, which I'll talk about in another set of slides. But we used that to set up our program at Lakeland, which started in 2011, so we have a good understanding of what it is that the geospatial industry is after in terms of student skills that are needed to work in the field. It's important to keep in mind at the most basic level that GIS can have two different meanings: Geographic Information Systems or Geographic Information Science, which is often abbreviated as GISCI. Geographic Information Systems is the computer system that processes geographic data and maps. We can then store, organize, display, and analyze spatial and geographic data through a GIS. It allows us to handle and manipulate and edit a large amount of data from various sources and to be able to map using various different layers and different types of geographic data. By contrast, Geographic Information Science is the scientific foundation of GIS, and this is really a multidisciplinary field that basically focuses on the underlying fundamentals of geographic information. We'll learn that geographic information in Chapter 1 is described as basically having a location. So when data has a location, it can be described as geographic information. And if it doesn't have a location, then it typically isn't thought of as directly geographic information, although it can inform geographic information by looking at the characteristics of the variables or attributes about those particular locations. We analyze geographic information and non-geographic information through spatial analysis. So we're very interested then in using spatial analysis to look at the relationships among different places and the meanings that that then brings about. In another set of slides in set 3, I'll be talking a bit about some of the examples of spatial analysis and spatial reasoning. Another big area of geographic information science relates to how we represent and understand spatial data. So in the geographic information science area, this isn't as much about how we do it on a computer as it is about the thinking that goes into it and the underlying understandings we make when we represent the world around us. Critical to that is the related field of geodesy, and geodesy is the study of the shape and size of the Earth. And until the technology that emerged in the late 20th century, we actually had a fairly rudimentary understanding of the Earth in terms of at a detailed level. And so our knowledge about that, especially with satellite technology, has improved greatly in recent years. We'll see examples of how that's used when we look at map projections and some other topics in the Geographic Information Science 1 class. And then also the theoretical and methodological foundations of geographic information science and of geographic information. An example of this would be to understand that the way that we map and represent geographic and spatial data has to reflect on how that data is classified and stored, how it is understood, what the rules of behavior are for various geographic objects that we put on layers and put in maps. And there are many different considerations that are taken into account in that area. So again, GIS, as we typically think of it, can be geographic information systems, which is more of the computer system and the technology itself. So think of it as many of the tasks that you'll do in your lab assignments versus geographic information science, which is more about the foundations and fundamentals. You'll be writing essay questions on this and reflecting on some of the fundamental thinking that goes into how we use spatial data in this course. And that's the end of the fundamentals slide set.